Hello everyone, welcome to another Teach to Code with Professor V. So today we're going to be looking at our Pre-Algebra Java class program. So let's go ahead and jump right into it. So I was looking through the Pre-Algebra book that I used to teach out of, and figured we could program an average and a probability would be fun. Oops, sorry about that. We're also going to look at sales tax and what was the other one I wanted to look up? Simple interest. So these will be some good methods for us to practice today. So let's go ahead and go to the bottom of our last method, which was the perimeter of the triangle. And let's go ahead and start building some new methods. This one is also going to return a type double. But the new one about this one is we're going to actually pass an array into the parameters. So if you haven't worked with an array is a collection of one data type, right? An array could be a collection of doubles, it could be a collection of integers, it could be a collection of objects, it could be a collection of strings. So we're going to use an array of type double, and let's go ahead and start programming. So the first thing we need is a place to store the actual average, right? So we need to define a variable, initialize it to 0. Next, we're going to have a for loop. So for int I is equal to 0, while I is less than n dot length. So the length of this array is going to be how long the array should run. So once it senses that I is less than n dot length, as long as sorry, I'm saying that backwards. As long as I is less than n dot length, it's going to run. And then I to increment our I by 1 each time. So I went ahead and did my curly braces here. So now for the average, all we're going to really need is average is plus equals. So we want to add this to each iteration of the array. Oops, man, I'm really messing up today. Sorry guys. So what we want to do is we want to take the average and go ahead and store it into n, which is the number set of our array, right? So each time we're going in, it's going to take in an array. It's going to pass the first number and add it to the average. Then it's going to go back in, it's going to add the second number of the array, add it to the average. And it's going to keep doing that because if you guys remember the average, right, it's simply adding each number and then dividing by the number list. Now I am thinking there probably does need to be an if statement here. Because what if the user does pass in some negative numbers, right? So trying to think of how we could do this though. Let's just go ahead and leave it a little simplistic. I could add that on later if you guys would like to see it, but because otherwise this video is going to be long. These formulas are kind of a little bit more robust, but essentially we would check if not average is equal to -1, but something with n of I, right? If n of I, if any of those numbers inside of the array is negative, then we shouldn't allow the user. But anyways, let's just keep pushing forward. Let's just imagine the user is going to use all positive integers for this. So next, after we have all the average stored within the average variable, we need to divide it by n dot length, because the length is going to tell us how many elements are in our array, right? So if there was 3 numbers, for instance, we would divide by 3, right? So this n dot length method is super helpful for this. And then the last thing we need to do is return our average. And you guys will notice that I put the average, the division part, outside of the loop. The loop is just to add the numbers, right? If we put this inside of the loop here, it's going to divide each time. So we don't want it to divide each time, we just want it to divide at the end of the loop. if that makes sense. If you have any questions, please leave them in the comments below. So, alright. So that's how we could program our average. We'll go to the test class in a while and test that out. So next I want to do public double get probability. And into this we're going to have two parameters, right? We're going to have the favorable outcome, and then we're going to have the double, so this will also be a type double total outcome. Okay, so let's go ahead and add our curly braces. So the favorable outcome is like, you know, how many aces, right, within a deck of cards. So there would be 4 aces, right, out of 52. So we'll practice this probability here. So like we've been doing, the first thing we need within our method is a place to store the probability. And the most intuitive variable to create is a variable called probability, right? Okay, so now if favorable outcome is less than 0, so we will do the check on this one. I didn't think of doing the check for the average, sorry. So like I say, if you guys do want to see it, I can amend a video real quick and, you know, add it after this one if need be. Or if total outcomes is less than 0. And then there's one more check we have to do here. So we don't want any probability that's going to be negative, right? So none of these should ever be negative. And in fact, with the total outcomes, it should never be less than or equal to 0, because then we would have a divide by 0, right? The total outcome is going to be on the bottom of our fraction, so you can't ever divide by 0, right? It's definitely an anomaly, and we could go into that later if you guys would like. So the other one we need to watch out for, oops, did I put outcome? Sorry, total outcome, is going to be if the favorable outcome is greater than the total outcome, right? Because that shouldn't happen. If you think about it, how could there be more aces than the total deck, right? So we have to be very careful with that. Okay, did I spell something wrong? Oh, I did, huh? Favorable. There we go. So that's the cool thing about using an IDE. Everything should line up, and it should tell you that your variable is like highlighted there. So awesome. I guess I'm having a rough day typing today. So alright. So if any of these happen, we're going to print out to the user something like outcomes must be positive, or just to keep it simple. So of course we could add more to it and say, you know, the favorable outcome has to be greater than, but we'll leave it at that for now. I'm thinking we could have done a nested if now, but it's okay. The first program is always, you know, a rough draft, so I'm sure when you're software developing, it's what they call iterative design, and it never ends, right? So probability is equal to the favorable outcome divided by the total outcome, right? So it's a very simple proportion here. So let me go ahead and highlight it here. Okay, everything's good. Cool. I didn't misspell anything, so I'm just double checking for y'all. So now let's go ahead and return probability. I'll go ahead and select it. Okay, seems like I spelled that right. So that's how we could calculate probability within a simple probability, right? Now, there are probabilities that use, gosh, now my brain's going blank. What do they call that? Permutations and combinations, right? if you guys want to see that, I can definitely work on that and we can see what we could build. So actually does sound kind of fun, to be honest. Sounds kind of complicated, but sounds fun. So this one we're going to get sales tax. So these are all things I used to teach GED students to help them get their GED. So now we're going to go ahead and program all this stuff in there. Alright. So the sales tax, we're going to need the rate, right, and the price. So the price is the percentage that we're going to charge the person for sales tax, right? In my state, it's like close to 8%. It's like 7.8 something or 7.9 something. So anyways, double sales tax. So we need a place to store our sales tax. So that's what we're going to be calculating, right? And then if rate, so the normal check, right, is less than 0, or price is less than 0, because none of these should ever exist, right? We can't charge negative percent tax and we can't have a negative price, right? Otherwise they'd be giving you money to when you buy their product, which wouldn't make any sense, right? It's just illogical. So system.out.println, we'll go ahead and say rate and price must be positive. Oops. Okay. So else, right? So if they do put in positive numbers, we should probably do the math. So the first thing I want to do is divide by 100. So what we're going to do is take the rate and we're going to divide it by rate. Well, we're going to take the rate, and store a new value into it, right? Rate divided by 100. So if you really think about it, when we're working with percentages and we're doing this stuff by hand, there's no way to really divide or multiply by a percentage, right? A percentage is a word, so when we divide by 100, what we're doing is we're converting the percentage to a decimal. So if we had 100%, right, we would only have 1, because the decimal would move 2 spaces to the left. So now we're going to have sales tax is equal to rate times price. So now we could simply take that decimal value, times it by the price, and we will get the sales tax. And then all we have to do is return sales tax. Alright. And then the last one is the simple interest. So if you remember simple interest, interest is equal to principal times the rate times the time, right? So the way we could find interest is by how much money you have borrowed times what's the percentage rate, right? How much interest did you say you were going to pay these people? And then time. So, and time will be measured in years, so we'll have to do that's why doubles will work perfectly for this too, because if you're borrowing money for 6 months, well, you could pass into the time 0.5, right? Because it would be half a year. So maybe we'll do a couple examples in the test class. So get simple interest. Oops, interest. If I could spell today. Alright, so we'll have double principal. We'll have double rate. And then we'll have double time. It was nice working out of the Pre-Algebra book because I was able to actually try some of the examples and just double check that the programs were running correctly. Interest, so a little debugging I was doing. So we need a place to store the interest, right? We could call it simple interest. I'm just going to call it interest. Now so we got to check all these again. So I know it's probably at this point where it's like, oh my god, we're always going to be checking for the user, right? Well, we got to make sure the user doesn't do anything silly. So we don't want to accept 0 as a principal, right? I mean, if you're borrowing $0, what the heck, right? the rate should never be less than or equal to 0, and the time should never be less than or equal to 0, right? So hopefully you guys are able to pause this video sometimes. I mean, if you want to challenge yourselves, right? It's not that you have to, but hopefully you're thinking more logical, right? Hopefully this is helping you and really helping you develop these algorithms and stuff. Okay, so if any of these are 0 or less than 0, we're going to print to the user values must be greater than 0. Would it be en or an? I don't know. Well, I'm just going to keep flying through it. If I make a grammatical mistake, please correct me in the comments below. I am okay with that. So else, if the user does push in something greater than 0, right, we should convert the rate first of all. So we should divide by 100 again because we're working by a rate. And then we can do the formula we have here, right? So interest is equal to principal times rate times time. And then the last thing we need to do is just return the interest. Okay. Make sure everything's spelled correctly. Having one of those days where I just need to check myself. So, alright, so now we're ready to go into the test class. Let's go ahead and test out what we're doing. So I'm going to go ahead and destroy this star and slash, and then I'm going to add it to the bottom of these other 5 lines now. Oops. I guess I didn't hit cut. Oops. Alright. So everything's commented out from the last couple videos we've done. I might just erase them, but I don't know, you know. It's up to you guys what you want to do. You can technically run all these methods at once, right? But it will get a little busy. So the first thing we do need, if we're going to do the average, because that was the first one we programmed, right? Our method, took in a double, right, of type array, an array of type double, saying that backwards. We're just going to simply call it my array. And then we're going to initialize it with at least 3 values. So let's do something easy, like 1, 2, 3. The average of 1, 2, 3 would be 6 divided by 3. So we should get 2, right? 1 plus 2 is 3. 3 plus 3 is 3. Or 6, 3 plus 3 is 6. You would take the 6 and divide it by how many numbers there are. 1, 2, 3. So we should get 3 divided by 6 is equal to 2 if we did everything correctly. I'm destroying my array. Okay. So let me do a couple new lines down. So next we're going to go ahead and do system.out.println. And we're going to go ahead and say average is, and we'll go ahead and concatenate the actual value. So we're using PA as our object, right? And then get average. So it already knew to pass my array into the method. It is something we probably should be doing, right? But anyways, you know, you could always call variables into your methods. Video will get a little bit long, but let's go ahead and do it. So let's just say double. So I'm going to initialize another variable. Ooh, it's not happy about that. Let me see. Oh, it's because I'm adding on. No. So let's say double aces is equal to 4. And then double cards is equal to 52. So I'm going to pass this into my probability method. So it's always better to use variables when you're working with a program. For this sake, you know, I've just been trying to make things super simplistic, but, you know, maybe it's good to practice this right now. So probability is, then we'll go ahead and call our object PA And then we will get the probability. Oh, it did it backwards though, right? The favorable outcome should come first. So it should be aces and then cards. Okay. Next, we're going to go ahead and just do normal numbers for these, just because the video is probably getting a little bit longer. So sales tax is, and then we're going to go ahead and call our object, and we'll do get sales tax. And into sales tax, we're going to say maybe it had a rate of 4.5. You're going to say 4.5%. And it had a price of, I don't know, $50. Okay. And if you wanted to do an easier sales tax, we could always do 10%, right? Or even 5%. At 5%, we should save what? $2.50 if I'm correct, doing quick math. And then last but not least, let's go ahead and do our simple interest. So do know you could initialize all these as variables, and that would really be the best practice. But, you know, I don't want these videos being too long. I want to try to get as much time viewed as I can, right, to help people out. So get simple interest. So in simple interest, let's go ahead and just pass one of the problems from my book. It had a 500 principal. Oops, the rate was at 6%. And then the years were for 3 years. So if you borrowed $500 at 6%, and you we're going to pay this back in 3 years, which I think for $500 is silly. They would have you pay it back sooner. Let's see how much we should pay back. So, alright, let's go ahead and run this. And I did figure out how to make this bigger. I realized in the other videos the standard output was small. So the average is 2, so that's good, right? 1 plus 2 plus 3, that was 6. 6 divided by 3 is 2. So the probability, oh man, let me go ahead and run it again, sorry. So the probability of the aces in a deck of cards is going to be 0.76923. We could do a simpler one now in a minute. The sales tax is $2.50, and then our simple interest would be $90. So we would end up paying $90 of interest, paying this off in 3 years. Now, a couple things I want to do is, what if we paid it off in 1 year, right? The interest should go down. And then for this, let's go ahead and do something simpler. So something that's obvious. Let's do a coin, right? Let's say we wanted heads. Well, there's only one head, right, on the coin. And there's 2 outcomes, right? You could either do heads or tails. So we should just get a 0.5. Okay, perfect. So we got the 0.5. And then notice how the simple interest, the interest went down, right? So according to how much time you pay the loan back, right, the interest will go down. So let's say we even paid it off in half a year. And I think this will be our last example. So you'd end up paying $15 of simple interest. So you could also pass in different time frames. They don't have to be years. I mean, you have to convert years to months, right? So 6 months would be half a year. Let's say it was 9 months, which would be 3/4 of a year, right? So 0.75. You'd end up paying $22.5 in interest. And then the one thing I could tell you guys that I will leave you with is never do a loan that's like 300%. So one time they wanted to give me a title loan. I think it was like almost for $1,000. I think it was like 2 years to pay it back. So that's 300% interest, guys. So just be careful with who loans you money, right? I would end up paying $6,000 in simple interest in 2 years. I'm paying them more money than they loaned me, you know. So be careful with some of these loans out there, you guys. If there's interest, I mean, I would never go higher than 30% myself. 30%'s high, but you know, in the essence of money, I'm not a financial advisor, so I will see you guys in the next video. Please leave a comment below. Let me know which what you would like to see next. You guys, you know, I'm super curious. I hope somebody's gaining some knowledge off of this. I hope I'm being helpful in some way, shape, or form. And other than that, I will see you guys in the next video. I hope you have a great day. Bye.